and gentlemen. Tonight we're going to look at section 10.2, which deals with some arcs and some angles that are formed within our circles. And then we're also going to look at some more chords and some more properties that we get when these chords intersect each other or when they intersect the circle and whatnot. So tonight you don't have a note sheet to go along with the video. So please make sure you kind of saw what you had to take notes on yesterday for the important information. So please make sure you do that tonight on your own. So feel free to, rewind the video as many times as you need to, pause it, and do whatever you need to get all of the information down. Now remember, definitions, new formulas, new theorems, that's the stuff we need to be writing down. And then if I were you, I'd work through as many examples as I need to that I present in this video to make sure you get the material down, okay? All right, so 10.2, we talk about arcs and chords. First up, just a couple new definitions. The first one is what a central angle is. Now, when you hear central, hopefully you hear center. Okay, we know where the center of a circle is, and in this example or this picture here, that's at point P, that's the center. So the central angle then is the angle whose vertex is the center of the circle. So we have that one central angle at point P. So it's this little guy right here we call, pick up the thing. We call that our central angle, okay, because its vertex is on the center. And then you see I have labeled minor arc versus major arc. Minor, that means it's small. Major, that means it's large. Now these definitions are a little wordy, okay, but just read through them and sum them up in your own words, okay? So let me erase all this and show the definition here. All right, so minor arc, that's smaller than half of the circle, so it's the little guy. And then the major arc, well, major means big, so it's greater than a half the circle. It's greater than a semicircle, okay? And then remember, in one circle, we have 360 degrees. So we're going to use that number a lot to figure out the different measurements of these arcs. And we'll talk about the measurement of an arc in just a second. So here's a more formal definition of what a semicircle is. It's literally just half of the circle. And when you think about it, when you cut a circle in half, we're talking about the diameter, okay? So we're just having the arc for the semicircle be defined as the arc that has the endpoints that are the endpoints of the diameter, okay? And hopefully that's common sense. We already know that, okay? One thing with arcs, because they are essentially, they're formed from this angle. So if I were to literally trace this angle, I hit point P, I go around, and without picking up the pen, I can curve around that arc. So essentially, when I talk about the measurement of an arc, I'm talking about this degree. Talking about the degree that it's formed by. Okay, so when we talk about measurements of arcs, we're going to look at the central angle, and they're going to be the same. So if you look at this next slide, we see that we have the central angle, angle ABC. Well, the measure of that is given as 60. So this angle is forming the minor arc AC, which is 60 degrees. So your central angle and the arc that it's forming, those are going to be the same degrees. And then I want you to take note of one other thing. To name a minor arc, we need 2 letters. A minor arc needs 2 letters. That changes when we look at a major arc. So we're going to have the same exact picture here. We have the central angle being 60 still, the minor arc being 60 still, and then I want to know what the major arc is equal to. Now, I don't want to call this major arc AC, because essentially you would have 2 arcs that are labeled AC, and I don't want to get that confusion. So we throw in a third point. We put point D on the circle between A and C. So then I can say the major arc is angle ADC. Okay, so then any major arc needs 3 letters. Okay, so now to figure out the measure of angle or arc ADC, I know a full circle, it's 360 degrees. So if I know I have 60 degrees right here for the minor arc, I'm just gonna go ahead and take 360 and subtract the minor arc, and then I'm left with the major arc. So hopefully that makes some sense. Okay, and that's how we're gonna figure out the measurements of these arcs based on the central angles measurement. Okay. All right. Just like we had congruent circles, congruent means that they have to have the same measurement. So if I want congruent arcs, now that I know that the arcs are measured by their central angles, if 2 arcs are said to be congruent, then they have the same measurement. So essentially they have the same central angle. Okay? And then here it says that you can have 2 arcs of the same circle, or you can have arcs of 2 congruent circles. Just make sure you understand, to be congruent circles, you have to have the same radii. Okay, so it can be in the same circle, or it can be in 2 different ones, and you can still have arcs that are going to be the same measurement. Okay, moving right along. Here's one of our first theorems. All right, theorem 10.4. It says, in the same circle or in congruent circles, 2 minor arcs are congruent if and only if, so that means this is true forwards and backwards, if and only if their corresponding chords are congruent. Okay? So here's a picture of that. Okay, we have this circle where we have chord AB and chord CD. Those chords are going to be congruent. Or they're marked congruent. So then, this says that if that's true, their corresponding arcs are going to be congruent. So what I always tell you guys, to make some sense of this, trace your chord AB. Okay, trace that chord. Now, if I want you to trace the arc that corresponds with that, you're going to go ahead and trace kind of to the left of these. There's your chord and your arc that correspond. So you're really looking at the endpoints of these chords or these arcs and figuring out where the corresponding part is. So hopefully that makes sense. So if chord AB matches up with arc AC, excuse me, or AD, excuse me, and then chord BC will match up with chord BC, okay? So because these chords are marked congruent, their corresponding chords, their corresponding arcs will be congruent as well. Okay, so hopefully you can see how those chords and those arcs relate. Okay, and we'll get lots of practice with these, so don't start stressing out too much. Okay, next theorem, we have 10.5. Now this one says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So bisects, remember, that means that it's cutting it in the middle. Okay, so here's the picture of that. You have the diameter that's running through the center. Okay, so E and G are on the diameter. And then the chord, DF, is perpendicular to that diameter. And you see that by the red box. Okay, so then the diameter is the diameter that's running through E and G, or through the center. That's bisecting chord DE. So because we know that, we're going to mark DE and FD congruent along with their corresponding arcs. DG, so I'm going to put this in a different color, DG and GF. So you just got to understand that not only does it cut the chord in half, but it also cuts the arc in half, which hopefully that makes sense because the full chord is DF. And then the full arc would be DF as well, arc DF. Okay, and if I'm cutting that in half, G is in the middle, so I'm just going to split it up. Okay, so hopefully that makes sense. So please make sure you're drawing these out, marking the picture up however you need to, and then starting to memorize this. Okay, moving right along. Here's two more theorems. We'll do 10-6 and then 10-7. So 10-6 says if one chord is the perpendicular bisector of another chord, then the first chord is the diameter. Okay, so you're going to have two chords right now, and they're going to be perpendicular bisectors of one another. Okay, so we have this picture. JK would be your diameter, and then LM is your chord that diameter is cutting in half. Okay, so then this just means that JK is the diameter. So if you have this picture, if you have the right angle and you have those red tick marks, you know that you can't have anything other than a diameter because nothing else would be in the middle. Nothing else would be cutting LM perfectly in the middle, if that makes sense. Okay. And then 10-7. 10-7 says in the same circle or in congruent circles, if two chords are congruent, then they're equidistant from the center, and that's going to work backwards as well because it's the if and only if. Okay, so here's that picture. We have CD and AB. Those are our chords. Those are going to be congruent. Therefore, that's going to imply that EF and EG are the same because if it's equidistant, it's the same distance away, so it's the same measurement. Okay, so we're going to get AB and CD to be congruent if and only if EF and EG are congruent. If F and G are the same distance away from the center. And that's going to go backwards as well and say, well, if I know my two chords are the same distance away from the center from one another, then I know those chords are going to be congruent because I can't stretch, I can't shrink, and be the same distance away. So hopefully that makes some sense. And then just always remember, those red boxes are there for a reason because I can't measure something at an angle. It's got to be straight to it, so it's got to be perpendicular. Okay, so hopefully that makes some sense. Okay, the last slide, just two examples to go through, and I want you to work through these. So here's the first one, and it actually says what theorem to use, but in a lot of your examples, it's not going to. Okay, to start off, we will, just so we know what to use and to get used to seeing these. But later on, you're just going to have to be able to look at this picture and say, okay, what do I have happening here? Here I have two chords that are marked congruent, AD and DC. So now I'm going to have my list of all my theorems that I've memorized, and I'm going to understand that when I see two chords that are marked congruent, I know that their corresponding minor arcs are going to be the same as well. So in order to find X, I'm going to set those equal to each other. Okay, so work through that. Make sure you get your answer for X, and then we will go over that answer tomorrow, okay, in class. All right. All right, here's one last example, okay? Now, this doesn't tell you what theorem to use. So you've got to break it down as to what this is telling us. So we want to find CG, okay? In blue, that question mark is what we want to find. All right, we know in green that AD, this whole thing, is 40, and CD, this little guy here, is 25. All right, so I'm essentially looking at how far away BE is from the center of the circle. That's what you're finding. That's that question mark. So what I need you to do is I need you to read through this diagram. You have AF, FD, GE, and GB all marked congruent. And then you know that the length of AD is 40, and the length of CD is 25. hopefully some of you are seeing something in that picture that's going to help us solve for CG. Now it is going to take a little thinking. Look at all of your pictures you've drawn. See if you can maybe add something to the picture that's going to help you solve in the long run for CG. Okay? So think through this. Get an answer. Make sure it's not blank when you come to class. Try to work something out, and then we will definitely go over this one tomorrow in class. Okay? So we've got a couple new theorems that we need to start memorizing along with yesterday's. Okay, so this is just going to be a continuation of theorems, all chapter long. So we've got to make sure we start memorizing them now. So when it comes time for the quiz next week and then for the test in a week and a half, we're good to go. Okay, make sure you write down any questions you have, and then we'll get them figured out tomorrow. Have a good night, guys.